1, 2, 3, 4, 5, 6 significant digits.
Oh, I thought you were talking about 0.
Oh, I'm sorry. How many significant digits are there? How many significant zeros? Oh, you're okay. If you were saying how many significant zeros and said 3, you'd be right. Okay, if that's what you meant. Okay. How many significant zeros are there? There are 3. How many significant digits are there? There are 6. Okay. So, if I'm doing a calculation, say multiplication or division with this, and this number has the least significant digits, my final answer needs to have 6 significant digits. Okay, that's why it's important to know what the significant zeros are. Got that? All right. How about we do this one? How many significant zeros do we have? That's a comma. How about it, Hannah? How many significant zeros are there? I mean, how many significant digits are there? No. All non-zero digits are always significant, by the way. Now, that's an informal rule. The formal rule is about the zeros, okay? Well, actually, I guess that is a formal rule because that is implied by the first two. You know, the formal rules, okay? But non-zero digits are always significant. Yes? One what? Significant zero or significant digit?
Significant 0.
Okay, can you tell me how many total significant digits there are?
4.
4 significant digits. Which zero, then, is not significant? Oh, no, that one's between 2 significant digits. That's the one-part rule. The one on the end is not significant because it is not between 2 significant digits.
Okay, yeah.
Okay. And while it trails a non-zero digit, the 2-part rule says you have to trail both a non-zero digit and a decimal place. And this one doesn't meet that rule. Okay? Now, here is the problem. Suppose I have a number like this, and I need to show only 4 significant digits. What is the proper way to write this number? Scientific notation. That's why one of the reasons why scientific notation is so important, but it's the only reason why scientific notation is required. Anytime you have a digit in the ones place that's not significant from rounding off or because of zeros or something, anytime you have a digit in the ones place that's not significant, you must write the answer in scientific notation. That makes sense? So let's remind ourselves about scientific notation. Because I know you guys know about scientific notation. It's one of the standards in physical science, and I know all the physical science teachers teach this stuff. Well, you probably learned it in math anyway, so there you go. All right, so let's see. What we're going to do is we're going to move the decimal place to just to the right of the first non-zero digit. Decimal place is going to go just to the right of the first non-zero digit. So here's our first non-zero digit. I'm moving it 1, 2, 3, 4 places. 1, 2, 3, 4 places. Okay? So I'm going to write this number now as 1.307. Now, because I did that, I can't just leave it like that. I have to have this. I can't change the order of magnitude. Okay, this number right here is 4 orders of magnitude smaller than that one. What I need is a way of writing it so I keep the order of magnitude, but show the right number of significant digits. Okay, so that's times 10 and to what power? 4. Because I moved it to the left 4 times. Okay? Grams of lead. So this is the way you write scientific notation. All right, now I'm going to plead with you guys about something. And despite my pleading, some of you are going to get this wrong on the test. That makes me cry. Sorry. Okay? I mean, I really won't cry, but it does make me sad. Some people are going to try to just move the decimal place 1 time. But that's not scientific notation. Scientific notation requires that the decimal be between the first and second digit, significant digit. Okay? Scientific notation requires the decimal place be between the first and second significant digit. Does that make sense? Everybody clear with that? Yes, sir.
What if there's only 2 numbers? You still have to move it?
That depends. So you're asking if there's like something like this.
Yeah.
Okay. I don't know, but the way, because this number was just presented to me in this way, I don't know its context. I have to assume these zeros are not significant. Okay? That being the case, I've got to move the decimal place right here. And my answer then would be 1.3 times 10 to the 4th liters of oxygen.
So it's always behind the first
Huh?
number. Always behind the first number.
Yes, between the first and second significant digit. Now, you don't have to write answers in scientific notation unless there's a reason to have to get rid of a digit in the ones place. Now, you might also get rid of digits in the tens and the hundreds place. But if you get rid of a digit in the ones place, your answer needs to be written in scientific notation. That's kind of like the rule. Okay? Like the rule. Okay? The rule. Like the bears. Yeah.
For it to be a significant zero, it's got to follow both rules or just one?
It has to meet one of the two rules. But one of those two rules is in two parts.
Yeah.
And so if it's going to meet the two-part rule, it's got to meet both parts of the two-part rule. Okay? So it's got to meet either the one-part rule or the two-part rule. But if it's meeting the two-part rule, it's got to meet both parts of the two-part rule. Okay? Does that make sense?
Yeah.
Anybody confused by that? All right.
I got a question.
I would be disappointed if you didn't.
You never, well, it's not really a question, but you never picked up the hypothesis.
You're right. I didn't. Thank you for telling me. But, I mean, I would have taken it up anyway, but I'm just saying thank you. Well, I would have don't blame me for it. We were too busy yesterday to get to it yesterday. Right? But since he mentioned it now, let's go ahead and take it up now, and we'll get it done and get out of the way. Okay?
I apologize.
Well, it would have happened anyway. I was just going to take it up at the end of class.
You were. I don't know. Can we turn it together though?
Huh? Well, you can, but if you don't have it today, you're losing points because it's not here. Why don't you have it today? Huh?
I did, though.
See, but I don't have a way of knowing that. So, I have to count off 5 points at the end of the day. Okay?
I wasn't serious, though. I didn't know it.
Huh? I said I went on one in class. Oh, number 4. Okay, well, what, you have a question about number 4? What is the question that's posed on number 4? You don't have to know. You have to pose a reasonable guess. Okay? What effect does changing the amount of table salt dissolved in an unchanging amount of water have on the solution? How much the solution expands when it freezes? That's number 4. Okay? What effect does it have? Well, you have to come up with a model that predicts that. Doesn't have to be a correct model. It just can't say something, metaphysical. Okay? It's got to be something that's reasonably based on science. I don't expect you to come up with the right answer. There's no right or wrong here. Okay? Just reasonable. Does that make sense? So what do you think the amount of changing the amount of table salt, what do you think that would do to the amount that water would expand when it freezes? On how much water expands when it freezes? You know water expands when it freezes. Everybody knew that?
Yeah.
Okay. How much if I continue to add table salt to a sample of water or any the same size sample of water, will it cause the expansion to be greater or less? You think it's going to be greater? Okay. Now, if that's what you think, you need to think now about what would cause that, and that's your model. What would cause that to happen? What do you think?
It's going to make it, doesn't it, it's going to be more dense, then it lowers the freezing temperature of the water, doesn't it?
It does do that. Now, how would that affect the expansion? See, you're doing what you should be doing, tying in all the previous knowledge you have about that. That's good, but you still have to come up with the answer of why it would affect the expansion or decrease of expansion when it freezes. And it doesn't have to be right. There's no right or wrong, but there's sound and unsound judgment. Okay? What do you think?
What?
The model. I'm looking for a model. You don't have a model yet?
I do.
What's your model?
If you add salt, then it will expand more.
But that's not a model. Yeah.
You know you're filming this right now, right?
I know I'm what? Yes, I am.
How's it going?
Okay. So, do you understand what a model is now?
Go over it.
Do y'all want to know? Huh? I'm not going to go over the whole thing. I'm going to take it out, and then I'll answer any questions you have.
Talking about a model.
What about a model?
What?
Let's take up your homework. All right. Why don't you all pass it to Veneri, and Veneri can put it right here for me, okay? Now, let's get back to significant digits. Okay? Y'all want some more examples of significant zeros? Yes? No?
No.
We're done?
Yeah.
Oh, well, good.
Listen to something more.